that's going forward. Okay, so I think this is, if you were to run it yourself, and I guess if some of you have laptops, you might be able to run this yourself. This is what you kind of need. You need Android Studio, an emulator. We're going to be doing the Android version of the code lab. There's an iOS one as well, but I don't do iOS development, so I'm not going to do that one. And we're going to be walking through what we talked about earlier, which is using MLKit to do some text recognition, some facial recognition. I don't think we're doing landmark detection, but yeah. And then also kind of key landmarks on face detection. So did everyone who wanted to see those Go links, those quick links? Okay. You know us already. Sweet. So if you go to those links, if you want to follow along, there are two things that you're going to want to download, so we'll kick that off and then we can kind of give more context. But it's mainly the source code, which is going to have two folders, a starter and a final. You'll want to start with the starter because the final has all the answers in it. And then there's the TensorFlow Lite model, which we'll be using, because as I mentioned, there are kind of two paths when you're using MLKit. You can use the models that we've generated and we've been fine-tuning, which are a little bit more generic, but will definitely help in most cases. Or if you're doing something very particular, you can have your own TensorFlow Lite models, and we can use that instead. And the model will take a little bit to download. We only really need one file in it, the TF Lite one, but you have to download the whole thing anyway. So yeah, so talking a little bit more, like some of this you heard a few seconds ago, but let's say it anyway because it's on the slide. So MLKit is cross-platform, and by that we mean it's iOS and Android, and it helps.
What about Windows phones? You said it's cross-platform.
Yeah, how many Windows?
Is it still a platform?
Oh yeah. I haven't seen a Windows phone in many years. So to my mind, they're like legendary or mythical things. So wait, sorry, does anyone here have a Windows phone? I'm sorry if you do. No, okay, good. So yeah, so we don't need to do it for this one, so we're fine. But so as I mentioned, so we have these pre-trained models in the kind of the default case. We train the model for you, and it has well-defined APIs. And if the APIs are not well-defined, I am one of the people who works on defining those APIs, so you can complain to me and we can work on it. So we help you do face detection, text detection, barcode reading and scanning, and you don't need to have an ML background, although I know a few of you do. And then we have the custom models where we host the model for you, and we can kind of figure out when it needs to be downloaded, what needs to be done on the client, and what can be done on with the cloud. So how does it work? So I don't know if you're aware of this, but Google has seen a lot of data. We've seen a lot of things, and so we can actually pre-train a lot of our stuff using some of the data sets that we have. The fun thing about I mentioned before that GCP has ML endpoints, right? The fun thing that the MLKit SDK does is it helps you separate between on-device and on-cloud. So if you want to do something on-device, it's faster, it requires less data, but it's going to be less accurate. So depending on what accuracy you're looking for, you can do something on-device or on-cloud. And again, like I said, hopefully the APIs are easy to use. In the case of the custom models, those are models that you train yourself. You kind of change them from TensorFlow to TensorFlow Lite because, again, size is an issue, so we're trying to get them a little bit pared down. You upload them to the Firebase console, and they're dynamically downloaded to devices if they need to be, if they're using that particular model or if they need access to it. You can A/B test different models with something called remote config, which we touched on a little bit earlier with Firebase. So you can actually test to see which of the models that you've defined yourself is working better or giving you better results. Yeah. So okay, so what are we going to do today? So we're going to do two things. We're going to go the easy path. I say easy. We're going to go the path where you don't define the models yourself, and you use the ones that we've pre-trained. And we're going to use text recognition to detect some text in images, mainly if you've seen a lot of the CAPTCHA I am a human things, it's like detecting text, is there text in this box? And also we're going to use the new face contour API, so you can actually see facial features. You could say left eye, right eye, you can say this is the shape of the mouth. And I'm just going to warn you, when we have the facial, the face contour stuff, people look kind of like ghosts, but it's Halloween, so I guess it's appropriate. Oh, you guys are laughing at that. Thank you. That was a really bad joke. And in the case of the custom model APIs, we're going to have Shannon drive that, and we're going to show how you can actually host it, how you can use it, how you can kind of define it. We'll actually walk through that, and how you can actually label images. So again, this is what I was saying. Android Studio is nice. This particular one, I mean, maybe knowing Kotlin is a little bit helpful, but like what we're doing here, you don't actually need to, so it's fine. If you have an understanding of machine learning models, that's a plus, and that would be really cool. I myself don't have a great understanding of it, and I can still use this, so it can't be that hard. So getting set up. So as I said, so we have the source, and the links are going to be on the bottom, and I think they'll be on the bottom of all the slides. And I don't know how we can share slides after, but I'm sure you guys can manage that. Sweet. And
we have recording anyway. So.
And you guys don't want to watch recording. It's so slow. Look at the slides. Look at the slides. They're faster. So we're downloading the two things, the source code and the custom model that we'll be using. So let's actually exit screen this mode and actually walk through that. Do I have network? I do. So let's actually, because not everyone has laptops, right? Yeah, let's walk through this. So this is the code lab. That's where that short link will get you to. And it's not that many steps, and it's very, very kind of guided. So one thing is you can do this code lab really fast and not learn anything about MLKit. That is not the point. We give you a lot of code snippets, but let's talk through what they're actually doing in a lot of these cases, so you can kind of understand as we're going along. So that's this guy. Okay, so we're going to go to the Firebase console. This is where you kind of configure and learn about Firebase products, right? So this is actually, if you're not actively developing and kind of working in the SDK, this is where you'll spend most of your time. This is where you'll monitor crash reporting, and actually let's take a quick detour and look at some of that. Because if I remember, not all of you guys know Firebase, right?
That's the point of this lab.
The point of this lab is to teach you MLKit. Now I'm going to teach you a little bit about Firebase. I'm digressing. So like here, for example, you'll have like a Crashlytics thing, which is showing you all of the crashes that you have. Or here you have analytics. You can have your dashboard. The network isn't loading, and this is a fake app anyway. But you'll have like dashboards where you'll have all of the metrics that you're seeing. So you can kind of manage it here. But so that's the Firebase console. So you can create a new project, which will be at the landing page when you get to this guy. Come on, log in. Yeah, so this is where you'll add a new project, and we're going to call it MLKit Code Lab. I have it already. I'm going to cheat there. And you can add a Firebase app. So if you go to kind of your project, you can add a new app right here. And so what you do is you pretty much define a bundle, and you get some configuration, which are like the keys and the app configuration. And you'll get that. It's something called a Google Services.json. If you're using Firebase, you'll get very comfortable with this. It'll be in your app all the time. So let's make sure in our Android Studio, yeah, we have a Google Services JSON, and here it'll have things like your project number, the Firebase URL. You don't actually need to parse any of this yourself. It's just when we instantiate and initialize Firebase in your app, we read from this JSON file. So it has to have all of the credentials and the project information. So, but we have that, so we're good to go. And we've added it there. Setting up the Android Studio project. So this is something that we only need to do because we're in Kotlin. Have any of you folks used Kotlin before? Okay, you guys all use Kotlin. Fine, you're experts in this. I don't need to tell you anything about it. Let me see if it's configured. Maybe it's configured. Let's find out. If it's building, it's configured, so we'll find it. Okay. These are the dependencies that you need for MLKit. They should already be there in the code lab, but just in case the versions have changed, you can double check here and make sure you're getting the right ones. And let's take a quick look. What versions do we have? 17.0.2, 03, yeah, good. And it built something. So yeah, so now we're going to run the app, which I conveniently did a little second ago. And you see this. These things aren't wired in, they're not really helpful, but here we have a bunch of images. that we're going to go through, and we're going to try and detect things in them. So the first one we said, text recognition. So this is where I said you don't actually, you can get through this code lab without learning anything about MLKit, because there's a lot of copying and pasting that you can do, but we're not going to cheat, so we're not going to do it that way. So let's see, we've gone past here. Okay, so let's talk through what we're actually doing here. So when we're running the text recognition, what we're doing, this is, so we're saying, hey, let's take this Firebase vision image, right? So this is the kind of landing page for most of the stuff that you're going to do with image recognition. So we're saying, hey, from this bitmap, let's actually make this Firebase vision image, and let's actually try to get a recognizer for on-device text recognition. So this is the one where we're saying we're not using the cloud model, we're using the on-device one, because it'll be faster, it'll be smaller size, and also it'll be cheaper, because the cloud APIs do have a cost associated with them. There's a free tier of them, but once you get past that, you'll have to start paying for them, because it does actually require compute on our side, so you're not getting anything for free. So we're processing this image, and then we're adding some listeners to it. So we're saying, hey, when we've actually processed that listener, let's actually process the result of the text here. And so this is the text that we're actually pulling out of the image. And then on failure, then print a stack trace. So let's add this guy here. Run text recognition. I think it's in main activity. Oh, wait, they're already all there. Hold on. Except not. Sweet. And so with that, if you notice, in a really kind of messy and not super clear way, it found all the text in that thing, right? So you didn't have to train any new models. You just pretty much said, hey, let me talk to Firebase. You should actually, on device, figure out the text and actually get it for me. So, oh, sorry, I was cheating. This is actually creating the text block. So it's just putting things around it in the places that we identified already. So what's interesting is, so if we go here, there's the find text and find text cloud, right? So if we go to non-Latin based text, right? Find text on device doesn't actually work that well. But if we do find text cloud, it takes a little bit longer, as I said. Maybe a lot longer, depending on your network. We're going to let that go for a second while we go to something else. But this will detect more things because this one only detected the English when it was on device. This guy is slow. Okay, let me double check actually. Yeah, we'll let that go for a little bit and see if we need to enable anything else. Okay, so that's text recognition, which was actually super easy, right? All we did was we said, hey, let's go to the vision recognizer, pull out what the text is, and then just to make it very obvious for us when we're looking at this demo app, let's actually put a little box around each of the words that we identified, right? Because this text already gave us the words and it already broke it down into chunks. Ugh. Network. Live demos are always painful. Okay, so let's see. Do you want to do face on my space? You can drive it from here.
Oh, that's okay.
I think we can probably go back to this guy.
Yeah. So the creepy ghost mode.
Creepy ghost mode, yeah.
So the face contour recognition is a lot like text. It'll analyze the image, and instead of doing little boxes around where it found text, it will identify features of the face like eyebrows, nose, mouth, and give you that little dot there. That's just a visualization to show you what it's doing. It doesn't always have to appear like that.
It never has to appear
like that. It never has to appear like that. Well, for the sake of this demo, it kind of does. But yeah, so if we go, and it's the kind of the same process. You copy the big blob of code there, which again, is this also on device?
I believe so. Yeah.
Yeah, because it works in real time, so it has to.
Yeah.
It can't go to the server and make you wait 5 minutes.
Yeah, but again, like you're getting a list of face things, right? So that's kind of effectively how a lot of the Firebase APIs work, where you're making a call and then you're getting kind of a properly typed version of that thing. That doesn't seem very complicated.
Just
Yeah.
asking about cloud detection or going into cloud or pre-trained model. So as I understand, like the aim of the model is to be constantly improved all the time. So does it mean?
I wouldn't say constantly improved. That's dangerous.
Okay.
Often approved. Often approved.
Sometimes.
Yeah.
So does it mean that if I run it today, for example, it recognizes me one thing, but we change the model in the cloud, upload it, I run it tomorrow, and the result will be something totally different?
Something better
or worse?
So it's unlikely that it will be vastly different, because if you think about historically the amount of data Google has seen versus how much it's going to see in the next few days, it'll massively change that data set. It's not tons, right?
I mean, you find some genius and you said like that's everything we've done is piece of
is wrong.
Yes.
Well, I mean that is one of the benefits of using someone else's trained model, right? There is a chance it would be better and it would be different.
Let's hope for it.
Yeah, thank you. Yeah, let's hope for it. We do a lot of A/B testing ourselves before we release any models to the greater public, right? So we're using them ourselves, like we're dog fooding them. If you suddenly see something failing on photos, maybe we won't actually roll that out to everyone. I'm kidding. It's not actually something that's happened. So hopefully it will be getting better over time if you're using the cloud ones, but we do have a lot of safeguards in place to make sure it doesn't get worse. We don't have a regression there.
But in case of the cloud, you cannot say that, like, I want previous model, please.
No, there is no way of specifying which model or which version you want. Yeah, you're just getting the current latest one. These models are not small. It would be complicated to keep track of all the versions, and like most people want to get the best version anyway and the most accurate model. So
But the question is also about, for example, regression or automated testing. When you expect some kind of results, when your application behaves one way and then...
you probably shouldn't be using the cloud APIs on your automated testing that frequently unless you're not running them that often. Just because, like as I said, there are charges associated with it. If you, like, ideally you would be doing things on device for automated testing in CI. Yeah, I think that's generally good practice in general, because like it's always a chance that your automated test like reruns a bunch of times because there's a weird failure case, and then you get like a huge bill. I've seen that happen before at previous companies. It's never fun. It's never fun. Sweet.
Yeah, you can copy the code and...
I think we might
Is
have it
that already
already,
there?
because I think I used the final
Okay.
example.
I've heard of Amazon nullifying bills if they're like a little accident.
I've heard of many companies doing that.
So does Firebase do that?
I've heard of many companies doing that. It depends. It depends. It depends. It depends. I would not count on it. That seems like a dangerous thing to count on, but
Gosh.
like I said, we try and make things work out.
You're human, right?
Okay, so let's see. So this is the fine face contour, so let's get a face.
Ghosty mode.
Ghost mode.
It's almost Snapchat.
It's almost Snapchat. Well, I mean, so the fun thing is, right? So the face contour. The point is not to make you a ghost, but to figure out where your eyes are, so you can put like funny sunglasses on, or you can put like a little sticker, right? It's exactly for this. That's what we've seen
So
people
this
use.
is how Snapchat is making.
Does Snapchat work on video?
Does Snapchat work on video? I don't know. That's a good point, because we work on streaming on streams. Like actually, so another digression. If you haven't seen this, and you probably haven't because none of you knew about Firebase before, the keynote that we gave on Monday, we had someone, Sachin, who's the head of our ML Kit team. He was on stage in really bad lighting and bad network, and he was talking into his phone, and it was detecting his face as the stream was processing. So yeah, so it wasn't just a static image. But I would definitely check it out and watch it.
Instagram is doing face swapping, I think. You have like a face swap feature in Instagram, which is like comic string.
Yeah, which this could do perfectly. I mean, like, look, it recognized exactly where her face was and got the whole thing, so it's perfect for face swapping. Sweet, but back to the slides. Yeah, we ran the app. Sweet, you want to talk about
Well, and if you're really concerned with the model being swapped out from under you, can always do your own custom model and upload it to Firebase yourself.
And I think also depending on what you're doing, right? If you have a very particular use case and you do have a team of data scientists, for your use case, your custom model might be better. Like, right? I mean, that's the point. So you're going to get more accuracy in the particular use case that you're driving, because our models try to be accurate in like the generic case, right? So again, this is the model we mentioned before.
Is this? Oh, okay. So we gotta go to the
Code. Yeah. So this is adding in the model interpreter. So where do I put them? Yeah.
I think it's also got this step where you actually put it in the console.
Oh yeah.
What is that?
I should do that. I don't think it's in my console yet.
Okay.
Okay. So you can talk me through it. What
Sure.
am I doing?
Yeah. Why don't you go to the Firebase console and open up your ML Kit Code Lab project.
Okay.
And under ML Kit, you select Develop.
Is develop? Oh, it's in develop. Sweet.
Yeah. And then click Custom. Oh, we gotta get started first. That's an important step to add. There, Custom tab. Yeah. And click Add Another Model. Or add the custom model. And use a cloud_model_1 as the name. And this name will later be a download. That'll be the name of the file that we download. And
Where did I download it? That's a question.
no,
What's the name of it? Oh,
it's MobileNet V1.
And then the TF Lite.
Yeah.
And this is in the bundle that you'll download with the model.
It's thinking.
Oh yeah, because it actually needs me to publish. So yeah, in a lot of the cases, the flow on Firebase will have you do something and then confirm it. So don't forget to confirm for some of these things, especially if you're making changes to something like the feature flag equivalent called remote config. I've also done this myself many times where you like change something, you're like, it looks cool, and then you don't actually publish the change. So there we go. Now it's actually published and it's live. So now let's go back.
Yeah, you can go to the code and patch it in.
I think we might already have it.
Oh, cool.
Model interpreter. Yeah. Run model inference. Sweet.
Is that the same one? Oh, yeah. Okay.
But why don't we talk through what we're doing here?
So maybe you talk it through, yeah?
Yeah.
What are you doing?
So gonna add the model interpreter to your main activity.
Mm-hmm.
And then you add the method for it as well, which is all in the actual code is in the code lab, so you can find it there. And
check the code maybe.
yeah,
Let's do that. Okay, so let's go through the actual. So in the main activity, the init custom model. So yeah, there we go. So yeah, so what we're doing here is we're specifying like the default sizes that we're providing or that we used when we were training our model and what we're going to use and what we're expecting to see. So here, because we're using a custom model, like Firebase doesn't know anything about it, right? And doesn't know what the model is expecting to see as inputs. So here we were just saying, hey, this is the type of input that we've trained our model using. And we're giving some specifications here. The fun thing is we're saying, the important thing is that we're saying, hey, only download this model if you're on Wi-Fi. And this is something that you please remember. If you're doing your own custom model, please remember to do this. Because I don't know if you guys can see this, but that model is like 30 meg, which is not big for a model, but is really big if you're on like Subway and trying to download something. So.
But how application behaves if you are not in Wi-Fi?
So if you're not in Wi-Fi, then it won't download it. So if it doesn't download
like
the model.
what happens next? Just say, I want to process, I want to get results, and it says now go to Wi-Fi, and then you can use an application.
Yeah. So actually, so we have the API, the objects that you get returned back, whether you're using on device or cloud, you have the same object that is returned. So it's relatively easy for you to have simple logic saying, hey, try to get the cloud interpretation, but default to on device at worst case, because on device doesn't need to download anything.
According to this code, it will use local source. Yes?
Exactly. Yeah. So you'll have because you'll have an original version of the model that you've shipped with your app. This is just so you can keep updating that model, and you'll get the latest versions. So it will have something to fall back to.
If require Wi-Fi is good practice, why it's not default?
Because some people don't necessarily want to follow. So I think this is something that Firebase tries to do. We don't want to force you to do something. There might be a very good reason. Maybe people only ever use this app on Wi-Fi. Maybe it
Yes,
actually will not work without it.
It should be still there, but it can be just defaulting to.
Yeah, it is definitely possible. It's something.
But as a developer, I would expect this to be there. For example, if I wanted to debug why it is not working on 4G, and there's nothing written about it in the code, I would be very sad. Like,
I think that there are definitely kind of trades on both sides. I think one of the tenets that, I don't know if this is like an officially a tenet or something that I just try to do a lot, I tend to not read documentation. I don't know about you. I tend to read methods.
No one does.
Yeah, exactly.
And use methods. And so there have been many things where the documentation is like, this thing is definitely doing X, Y, and Z, but there's no obvious way to notice that, and you just don't expect it. As you said, like it becomes challenging. But yeah. So this is the fun thing. We're saying enable model updates, right? Because we could say that you should just use the model that's on the device, right? But here we're saying, hey, if there's a change to the model, we do eventually want to try and update it whenever you're on Wi-Fi. Different download conditions. Again, as you notice, this is the local source that for the model.
Will it download the full model from cloud or just default?
Yeah, so that one I am not entirely positive if we download the full model or just the diff. Yeah, I don't know. I don't know if we do how we would interpret the diff actually. Yeah, I don't know. I don't know if
Oh, it's really hard to have a diff between models.
Yeah.
I would say.
But
So that's a valid point.
I mean, I know in a lot of other cases, not necessarily this one, like in the case of remote config where you have a bunch of keys and values, if we notice a change, we download all of it just in case. If you're downloading a diff, I mean, I guess you could do a hash of what the current state is that the device knows about, send that and try and do something there, but like you don't necessarily know at what snapshot and what version that was. Like I think there would be a little bit more overhead on the developer side, but so that's why I'm not sure which way we do it. But sorry. Okay.
I think we gotta update the Gradle next.
Sweet. What are we updating Gradle for?
And gotta add the AAPT options.
This guy.
Yeah, so you don't end up squishing your model down.
I mean, that would be not great.
Yeah.
Yeah. Okay. Yeah, and so this is why we're using the TF Lite, right? Because we're already kind of trying to make it the smallest version of the model we can get, as opposed to using the other TF models. So we've already done compression on it in a way that our kind of model interpreter can understand. So we're not doing we're not doing compression that it doesn't know how to parse properly. Okay. Let's run it on this guy. So what is this one? Is that 5? 4? 4?
Yes.
Find objects.
I believe so.
Found a tennis ball and a racket, and there was 0% chance that there was tissue, which is good to know, but I don't know why we thought it was anything there. So, but if you notice, it definitely found tennis balls. Definitely found tennis ball. Probably found racket.
But the probability of a racket being there is fairly small.
It is, and I think that if you can see, it's because there are the primary focus of this thing is the tennis ball.
And it's partially on there.
Yeah.
So it's
And also-
It's on the angle.
It's on an angle.
Yeah.
But also, remember, this is the model that we made.
It's not an
You mean
actual
particular?
real model.
God, no, that would have been terrible. We wouldn't have had a tennis ball at all. It would have been like kiwi. Actually, kiwi wouldn't have been that bad. That would be pretty close. But no, it would not have been anywhere close. I think, so that pretty much
That's near
that
the
covers
end
it.
there.
Yeah. I think so. The one interesting thing is on, a lot of these things are interesting, is that you can have a whole bunch of, I mentioned before that you can do A/B testing of your models, right? So I'm going to talk like kind of quick with remote config. So you have all of these model names, right? So what you can do is you can run an A/B test in remote config. Let me quickly show you how that works. So remote config, you have a bunch of parameter model name. The default value is going to be this cloud model 1. Again, remember, publish changes, always publish change. Okay, so A/B testing. Let's create that experiment with remote config. So we're saying test, I can't type fast. Test that model. Let's target people in the code lab, and let's target 5% of users. It doesn't have any activation events, that's cool. What I want to determine is, okay, let me see if by having a better model and being able to identify something, people spend more money. And I also want to see people use it more often because of that. Daily user engagement, I can't do it yet. And people, no, retention 7 days. Yeah, that's a good one. Okay, so now all I'm doing is saying, hey, these are the things that I'm A/B testing, the model name. So in the case of the first one, I'm using the default, which is the cloud model 1. But I've just created a model that I think is going to do better. Not the same one. And I have that, and I can just kick off my experiment. It'll go to 5% of my users already, like automatically. And if I instead in my code say, hey, in the main activity where I said the name of the hosted model name, here instead I do something like remote config. I don't know if I have remote config in this app. .get instance, .get, this is not exactly the code, but it's like conceptually like this. And you can look at the remote config documentation, but get parameter, and then it's going to be model name. If you do like this, then you pass it in, then you can A/B test which of those models is doing better and for revenue. And then once you actually want to, that's the wrong thing. There we go. And then, so you'll start the experiment, that's cool. But what really is exciting is then when you roll it out to people, what you'll do is you'll press a button, say roll out, and you'll choose, I don't think it's gonna let me roll it out yet, yes. You roll out which one you think is doing better based on the metrics that we're providing. We'll identify a leader for you, but sometimes you're really just saying, does this model, which is cheaper or smaller size, does it work the same? So you have an option of which one you wanna roll out. And then it just goes to all of and it'll update so all of the people are getting that value. Yeah, so that's how you can kind of A/B test your models as well. And you can use A/B testing for other remote config things as well. It's just this is a very good example when you're like playing between different models. I think that's kind of it. Yeah, and so that's how you can do a lot of really good text and facial recognition without, I mean, like, the on-device stuff or the on-cloud without our own model, we didn't need to know anything about ML at all, right? And it just works, which is kind of cool.
So what you can do text recognition, face recognition, and...
You can do barcode recognition and scanning, right? So it'll have an image that says, hey, this is a barcode, and let me scan it. Do that. What
What
other
about
Objects
captures and
developing
recaptures?
everything.
captures and recaptures? That's a really good question. I don't think.
It's designed not to.
I think it's explicitly designed not to, because you have to not be a robot for that one. But again, we are training those models with us, so they're. If you're using our
Maybe you
ML
can
kit
use
for
your own custom models.
yeah, the custom model, maybe. Let's see. Okay, yeah. So we have landmark detection, image labeling, barcode scanning, facial detection, and facial contours. I think so. We saw in the example of contours, right, with Grace Hopper. So before, what we could do is we could do kind of just the outside, where like this whole thing is a face, just like we detected the tennis ball, where like this is a face. But now we can do contours. So that's the kind of improvement there. But yeah. And we've been so this launched. So MLKit, like the very first incarnation of it, launched in May, and we've been adding new things to that kind of pretty regularly. So it's something that we're pretty heavily invested in. So we're adding new things that you can detect quite frequently.
Thank you so much. If you guys, we have a little of time left, so if you have any questions to ask,
Just come and see the code
just
and
come
ask.
over and yeah.